Hi friends, welcome back. Today we're going to be talking about proportional and non-proportional relationships. 3 different ways: tables, equations, and graphs. So take a moment to write down this information. Make sure to pull out your notebook and take these notes. Take a moment, pause the video, write down this information, and then we're going to talk about how we figure out how these are proportional and non-proportional. Okay, so the formula for figuring out the proportional ones are going to be the rate of change is going to be constant, and the graph has to start at 0, 0. So it's got to go through that origin. How do we find the rate of change? The rate of change, remember, is the dependent variable over the independent variable. Now, your dependent variable is your y, and your independent variable is your x. This is going to be our rate of change formula. Okay, so how do we use this? Let's take a look at this first example. We're going to talk about tables first. In this table, the number of hours worked and the amount of money made, or the amount of money earned. What we're going to do is figure out how much it is per hour. So we're going to take the dependent variable. This is our x, this is our y. So we're going to take our y and we're going to divide it by our x. See, our y divided by our x. So if we have 36 divided by 4, we end up with 9. So we are making $9 per hour. Let's look at this next one. If we take 54 and we divide that by 6, we end up with $9. If we take 90 and divide it by 10, we end up with $9 per hour. And for the last one, if we take 153, divide that by 17, we end up with $9 per hour. $9 per hour. So in this case, the rate of change is constant, okay? So this is a proportional relationship. So yes, this is proportional. Now let's look at the second example. The number of classrooms and the total number of students in the school. In one classroom, we have 23 students. So our rate, we're going to do 23 divided by 1. It's going to give us 23 students. It might help if I put, this is our rate here. Now we do 46 divided by 2. All right, well, that's going to give us 23 students. All right, if we do 72 and divide that by 3, we end up with 24. All right, and then 84 divided by 4 gives us 22. Actually, let me just double check. Sorry about that, 21. I don't know what I'm thinking here. That gives us 21. You can see here that the rate is not staying consistent. It's different for every one of these. You always want to check all 4 of these, because at the beginning we were like, oh yeah, these 2 match, so it's probably proportional. But then we get to here and here and we realize, nope, that's not proportional. So we say not proportional. Okay, so that's how you do it with tables. Now let's talk about equations. Equations, remember, our linear equation, and linear just means line, is y equals mx plus b. Here's what's important here. Our m is our slope, which is also our rate of change. Those are the exact same thing. Slope and rate of change mean the exact same thing. Our b is what we call our y-intercept. Oops, y-intercept. It's not your y. This is your y over here. So make sure that you don't want to just call it your y. You're going to call it your y-intercept. That's where it crosses on the y-axis. When we're talking about this in terms of proportional and non-proportional relationships, this is also your starting amount. So starting amount. Starting amount. Now remember at the beginning I said for something to be proportional, your rate of change is constant, but the graph also has to start at 0, 0. That means it's going to intercept the graph at 0. So take a look at example 1 and example 2 and make sure to write those both down in your notebook. We have this equation here has a rate of change of 5, because it's what comes in front of our x. This one also has a rate of change or slope of 5. However, you'll see on this one we have a starting amount or a y-intercept of 10. So this guy over here, we have a starting amount or a y-intercept of 0, because I'm allowed to add 0 to anything. So this case, proportional, because it crosses through our y-axis at 0 and the rate of change is the same. This one, the rate of change is the same, but it starts at 10. So this would be not proportional. Not proportional. So it's a little tricky there, but just keep that in mind. Okay, so the next one that we're going to look at is graphs. Let's determine, so let me write this on here, graphs. So we talked about tables, we talked about equations, now we're going to talk about graphs. I have two graphs here. Example 1, you may want to write these down, and then example number 2. And in both of these examples, you can kind of see that I have the cost on the left and the days on the right. Now remember, our formula is the dependent over the independent variable. Our dependent is our y, and our x is independent. So we're going to take this guy and we're going to divide it by this guy. In order for us to do that, we've got to have a couple of points. For example, if we go over 1 day, it's $50. So 1 day is $50. Let's try another one. 2 days is $100. 3 days is $150. And I bet you're starting to see a pattern here. 4 days is $200, and 5 days is $250. Now, in order for us to find that rate, we would take our y divided by our x, and we would get 50 on all of these. So it is $50 per day. $50 per day. Okay, so, oops, and for this last one. So this one, yep, this is proportional. Now, let's take a look at this next example. You'll see that it's proportional, $25 for 1 day, $25 for 2 days, but notice that it's starting at 25. So it's actually, for 1 day, it's $50 because it started at 25. This does not start at 0, 0, so straight away we know that this is not proportional. Proportional. Excellent, I hope that cleared it up for you, and I look forward to seeing you next time.